So we have several projects that you might be working on this week, and here's one of them around this simple cipher. I want to get this problem started with you and take care of two things. Number one, show you what I mean by randomly generating a key for the cipher, and number two, um, how to get started with the dictionary a little bit as well. So if you haven't read that assignment yet, it's probably worth pausing and going and reading the assignment so you have a little bit of context, because I'm not going to explain the whole thing here. All right, so maybe you paused and read it. Maybe you already read it. Here we go. So there's four parts to this A, B, C, D. So part A is what we're going to focus on right here, which is generating the key. So the idea the idea behind this is I'm going to take the base alphabet A through Z, capital A through Z, lowercase, and um, create another value A through Z, capital A through Z, lowercase, to stand in for that as part of my cipher. And so the cipher you can see I've set up is a dictionary. And if I run this file without doing anything, it tells me I expected the key to contain 52 entries, but it contains zero. I haven't added any yet. So to help you do this, I've created this function called generate all letters. And if you look at this code real quick, it creates a list where it adds in A through Z, uppercase, A through Z, lowercase, and it returns that for you. And instead of just creating it as a static list one time, I did it this way so you can actually have two of these lists if you want to. So this stupid, simple, easy way that's a bad cipher, it's a terrible cipher to do this, would be we can say for letter in, what did I call that again? Let's just come down and copy it. Generate all letters. All right. In generate all letters. And I could say cipher of letter is equal to letter. So this is a non-cipher cipher. I think this is actually, oops, sorry, I need to put a space on each of those, and let me just make sure my aligning is all correctly. That looks better. So now I have a non-cipher cipher because the letter that comes in is the letter that goes out. I'm not actually decrypting or encrypting anything, but just to code small, just to make sure it's doing something. When I run this now, you can see the first error went away. It now contains 52 entries, but I'm not actually encrypting anything, so I get the other error messages. But this again is a bad cipher. It's a very poor cipher. So one of the ciphers is I could always do it as the next letter in line. So each letter could be letter plus 1, letter plus 10, letter plus 13 is a famous historical cipher out there. In which case, when I get to the last 13 letters, I have to then roll them around to the first 13 letters. So if I had to do some if statements and some logic there. But what I want to do is just totally randomly generate this. I want it to be nothing predictable. It's still a cipher. It's still crackable if you have the right things, but I don't want it to be predictable. I don't want it to be something that everybody says, well, they just added 5, 1, 2, 3, 4, 5, 6, 7, whatever it's going to be doing. It's just going to be a jumble of letters. So the way I'm going to do that here is I'm actually going to create a second list here. So I'm going to call it cipher letters. It's going to be another copy of all the letters here. That's why I did this. So I have two copies of them. So I have one that I'm going to loop through the letters as is. And I'm going to have another one of them that what I'm going to do is I'm going to randomly select one of the letters and take it out of the list until I've gone all the way through this and every one maps to another one. So think of it this way. I have a bag full of Scrabble tiles, A through Z, capital letters, A through Z, lowercase letters. And I have another set of the basically A through Z written down. And so for A, I'm going to reach into the bag and grab a tile at random, and it's going to be one of the letters. It doesn't even matter if it's the same letter. I mean, theoretically, it's possible my cipher ends up exactly like this, but that would mean choosing 52 times the exact same letter. Very, very unlikely. So again, I reach in the bag. My cipher could be Q. My cipher could be whatever. So let me show you what it looks like right now, by the way. I do a print cipher. So we can see what it looks like now, and then we can see what it looks like later. So right now you can see with the map, A is A, B is B, C is C, D is D. And we want it to be something different. So what I want to do instead is I have this bag of letters I'm going to grab from, and every time I get a letter, I want to randomly select one of them to go and draw. So I'm going to create a random index here. All right, and that's going to be notice I imported it up here, random. I'm going to use the random class to generate a random integer somewhere between 0 and the length of cipher letters minus 1. So why minus 1? So again, I want to pick one of the values inside of here, and the number of items inside of there is the length of cipher letters. Starts off at 52. And every time I pull one out, it's going to be one less, but that's not why I have minus 1 here. So the reason why I want minus 1 is because the first index of a list is 0. The last index of a list is size minus 1. So that's where I want to pick a random number between those two numbers. All right. Because I think, if I remember right, random number will go up to including the last number. And so if I don't make the size minus 1, well, we'll try it here in a second. But if I don't make that size minus 1, I think what's going to happen is it would blow up. So now, instead of setting the letter to itself, what I'm going to do is I'm going to use cipher letters dot pop. Now, if you remember from the videos this time, pop has a very specific connotation in a dictionary that's the same in a list. So when I type random index inside of here, it goes out to this index and it removes it from the list and returns the value. So it's going to take this out of the list. The list is going to get smaller each time until we've mapped it together. So now you see, simple little code. I have a whole bag of letters, A through Z. I'm not shuffling them up. They're actually in order. But I'm going to randomly grab one of them based off of its index. I'm getting a random number, which is the index. And then I'm going to pull that random number out, take it out, and assign it to be that letter. So now when I run this again, oop, I got an error. What did I get an error on? Unsupported type for list and int. Yeah. Cipher letters is a list here. My minus 1, I accidentally put inside of that. It needs to be here. Minus 1 here. So the length of cipher letters minus 1 is not right. It's the length of cipher letters minus 1. So how long is the list? And then I take 1 away from that. Not, cipher letters is the list. I can't take 1 away from a list, right? What is menu minus 1? No. What is the number of items on the menu minus 1? That's what we're saying. So let's try that again. Yes, there you go. So now we can see random number generator. Anytime somebody types an A, instead the cipher says to use a Q. Anytime does a lowercase a, the cipher says to use a C. And so now I've got a truly randomized cipher here that I think should be different every single time. Let me run it again and see. Yep. So now the second time I run it, A is now pointing to a lowercase r. So you can see it could be any letter of the 52, and it just mixes them all up back and forth and gets them out there. So let me just show you, let me just double check. If I do this without the minus 1, let's see if it breaks. Yes. So you see pop index out of range. So it doesn't tell me what the number was in this case, but the minus 1 is essential because I need to not ask for the size of the list. I need to ask for the size of the list minus 1. So I just wanted to confirm, because if I didn't need the minus 1 there, I would have just never picked the last item on the list, which wouldn't necessarily be a problem. It just means that the last item would never get selected. The last item would always be Z, whatever, so basically Z and Z would always line up to each other. And let me double check, but I don't think it does. Yep, so Z is Y in this case. So what was Z here? Z was W in this case. So yep, it definitely is randomized inside of that. All right, so there's a little help getting started. Now, as kind of a quick guide, the decrypt key is the exact opposite of the encryption key. So whatever the key is, A, in the encryption key, well, it should be flipped. So the R should point to A in the decryption key. the N should point to B in the decryption key. So it's essentially flipped. So your job there is to flip the key and values. And it's not as simple as that. You have to do some looping and some work to make that happen. But it is as simple as that. You just have to flip those. Encrypting, again, we have a string that's going to go out. What we need to do is take every letter in the phrase that comes in and flip it with the key. So every time you see an A, it becomes an R. Every time you see a B, it becomes an N. And not literally in this case, but you look up in the dictionary and instead print out the other one that's inside of here. And then decrypt is exactly the opposite. It just uses the decrypt key instead of the encrypt key. And there's some testers here to help you work through that. And then hopefully this problem comes together fairly quickly after that. If you have any questions, reach out and ask. But I definitely wanted to show you both quickly how we create a cipher that's empty. You see, this is a dictionary. And then we can add one letter at a time by just simply setting that letter by looping through the generating letters to some randomly generated letter in this case. If you wanted to do a little bit different cipher, we can try it. You can do it different ways, but I love this randomly generated cipher. It makes it much, much harder to figure out what the decryption scheme actually is. All right, so good luck with that. Let me know if you have any questions.